All right. So let's take a look. I have in my notes. Well, actually, let's talk about just quickly what next week's going to look like. So next week is finals week. I'm going to have our exam up on Blackboard sometime during the day on Sunday. So let's just say by midnight Sunday this weekend. It'll be designed to take about an hour. I'll probably give you 2.5 hours time limit on it, just so it's not a time stress type situation. You just have to finish it sometime during finals week, so sometime before midnight on Friday, so I have time to grade it over the weekends to get grades in on the following week. I don't care when you take it, but you have to take it all in one sitting. So make sure whenever you sit down to do it, you have a 2.5 hour time slot available, even though it should take you an hour or less. That's how it's designed. Closed book, closed note, don't cheat. I guess the one thing I would say though is try to put yourself in the shoes of if we were taking this exam in the normal classroom and you had a question about one of the questions you came up, sometimes I'll give you a little hint. So if there's something that you do know that you're just having kind of a brain fart or something, glance at your notes, give yourself a reminder, and then, go and show me what you're capable of doing. That's what I want to see on the exam, is what you're capable of doing. Don't work in groups. So if you have to peek to remind yourself of a concept, that's okay, but don't be copying stuff out of your notes, things like that. We'll spend some time probably maybe in today's class. In fact, actually, why don't we do that now? I'm going to go through the slides quickly, just show you the things that I think are going to be most important on the exam. And then if you have questions about those that you want me to go over on Wednesday, I will. So on Thursday, I will. So between now and class on Thursday, think about if there's things that you want me to specifically review, and I will. Otherwise, we'll just keep finishing up our final Android stuff. But so I'll just spend a few minutes here going through our slides, but then we're going to get back into our Android stuff. So any questions about the exam for next week?
Is it the same format as like your other exams, 10 questions?
Yep, 10 questions. Yep, the guaranteed there'll be at least one conversion question as usual, but yeah, same format. All right, so let's start. Actually, let's just go backwards here. All right, on the exam, I'm not going to ask you any questions about specific sorting algorithms. You don't have to go and memorize algorithms or searching algorithms, but you should be able to work with objects conveniently. If I tell you to search through some objects looking for something, you should be able to do that one way or another. At the very least, a linear search, just write a for loop to go through. So I would say focus on algorithms of things. So if I say you have a array list of player objects, I don't know, let's say that they all have a scoring number of points they scored in the last game, sum up all their points to tell me the total number of points the team scored, something like that. So be able to work with different kinds of objects and pull data out of them and do stuff algorithmically with it. That isn't to say that these different searches and sorts aren't important, but they're a means to teach you algorithms, not so much to memorize a searching algorithm. You can always look up that before you need to write one, or just use the built-in sort. But searching and sorting algorithms are good algorithms to practice the logic of algorithms. I won't ask a specific question about merge sort, although recursion would certainly be fair. I think recursion will probably find its way on the exam in at least one question. It probably won't be an incredibly difficult recursion question, probably somewhere in a similar complexity to like the factorial problem, but expect there to be a recursion question on the exam. The idea of interfaces as well as threads. I won't go in, I'm not going to ask you about details behind the scenes of like, the idea of multiple processes and threads and, how CPUs work. That's more of an operating systems thing. But, to be able to create a thread that does something in the background should be something that's in your wheelhouse. Memorizing it, I think, would be less important. I would probably give you a framework for it or something like that, but kind of understanding how the sandwich is put together, right? How, we extend the thread class, we write our code inside of public void run because the thread class implements a interface called runnable. And then we tell the thread to start. So really, there's a lot of object-oriented pieces there that are important to, it's not so much, we happen to be using in the context of threads, but the reality is that, we're talking about inheritance there, we're talking about objects there, we're talking about implementing interfaces there, and what's the job of an interface. So make sure you understand the difference between interfaces and classes, and you understand the difference, you understand how to inherit from another class that either you wrote or somebody else wrote. So really, we're extending the thread class by inheriting from the thread class with our own version of a thread. And with that in mind, understand the difference between blocking versus non-blocking code. So kind of the idea of when would we create a thread to do something. Design patterns. I'll probably ask you about design patterns. We're going to be talking about another one today. These aren't going to be super detailed questions, but it's more going to be just that concept of, there's a lot of times what you'll hear in, lectures or something is kind of this idea of what's called best practices. A design pattern is kind of an approach to best practices. So a proposed good solution to common problems where we can say, a common problem can mean different things to different people. So we've looked at a specific design pattern that we've been working with lately called MVC, Model View Controller, that says keep your data separated from your view, separated from your logic. That's what Model View Controller effectively indicates. Otherwise, things are going to get all clumped together and it's going to be hard to maintain your software. So best practices for writing larger software applications that have a user interface plus some logic plus possible data storage is to keep those things separate and then connect them to each other in some way. Today, we're going to be looking at another design pattern called the Singleton design pattern. We'll talk about that in a few minutes. So really maybe the concept of design patterns in general, and then I might ask you specifically about MVC. So I would say you definitely want to know what MVC is and why it's important. I'm probably not going to ask you specific Android questions. Not that it's not interesting, but Android is really our way of saying, of almost proving that, hey, the language doesn't matter. As long as you understand the basics of how do human beings solve problems, remembering stuff, asking questions, repetition. And even a language you already know, we can throw you into a different, a different playground like Android Studio, and say, here's the nuances of Android. How can you take your knowledge of Java and apply it to Android? So while I might say that some question about Android might be fair game, I probably will avoid them, because this course isn't about Android, it's about programming. So any question I might ask you that borderlines asking about something with Android, it's going to be more of core programming mentality rather than something specific. All these things were more history of Android versus iOS. I won't ask anything about that. Not that it's not interesting, it just gave us a foundation for what we were working with. Same thing here with Android application life cycles. It's important if you're an Android developer. It's something you'll work with all the time. Not something I'm going to be asking you about on the exam. Same thing with the R class. Same thing with gravity. Okay, so that's the more recent stuff. Now let me go back to the stuff before the midterm and see if anything sticks out as something that you should know by now. So at first we reviewed and did our transition from Python over to Java. So I'm not going to rehash that. These are things you should be very, very, very familiar with now. Like I said, there's going to be at least one conversion question, so make sure you're familiar with those. That could come in the form of, convert from octal to hexadecimal. It could be convert from megabits to kilobytes. So know both of those, the idea of going from sizes or speeds, and also going from bases. Usually I only use one question on exams for that. If I'm desperate for another question, I might throw a second one in there. So make sure you don't lose 10 to 20 points on the exam because you didn't know how to do something that should be second nature by now. These are things you should definitely be able to do. String manipulation are kind of favorites of mine for, asking questions about, write a method that does this, write a method that does that. I like string manipulation type questions. So make sure you're familiar with strings, building strings, keeping, removing the vowels, counting the number of spaces, that kind of stuff. These are, all little algorithmic programming kind of drill questions that kind of show me your programming competence. Because remember, on an exam, it's kind of different than a homework assignment. I'm not asking you to spend 2 or 3 hours kind of drilling into a problem. I'm asking you to kind of show me the result of your hard work on the homework. Can you write something relatively simple, not trivial necessarily, but relatively simple in code, proving that you've gotten a competency in writing software now, and you can solve relatively simple problems fairly quickly. And then, with the point being that when I give you a homework assignment, you should be challenged because you have time to sit there and think about it and debate it and work in groups and that kind of stuff. But just under the hood, I like string manipulation questions, if for no other reason than it's kind of easy to come up with a lot of different exercises dealing with strings. And as usual, there'll probably be at least one, if not 2 questions on there where I give you some code and ask you to tell me what that code does. So you should also be able to read code. I won't ask anything about bitwise operators. You'll be dealing with them next semester in the 325 class. And related to the 325 class, we have to see, it's a possibility, because right now that class is huge because of our transition over to the new program. So we have the current 200 students as well as you guys probably taking 325 here in the spring. It's possible we're going to split that into 2 sections. I think it's likely they'll meet. Well, I'm just going to leave it at that for right now. It's possible we're going to split it into 2 sections. I don't know if it will be Dr. Locklear teaching both sections or if I'll teach one and he'll teach the other. I teach our graduate architecture classes, so that's possible. We might also just leave it as one big class. So I'll let you know as soon as I know, but every one of you will be able to take it is the punchline. Because I know there's some people currently on the wait list for the class. The class has, I don't know, something like 40 some students in it right now. We'll figure out one way or another, and everybody will be able to, who needs it will be able to take it, but just giving you a heads up. Okay, so again, no bitwise. You'll be dealing with that in the 325 class. Same thing with bit shifts. That's just something I kind of showed you as trivia stuff. Definitely be able to work with arrays. Those are another kind of question that I like for algorithm stuff. You know, take an array, manipulate it in some way, that kind of stuff. I probably won't ask you to use a scanner on the exam. Getting user input and stuff is not something I typically am going to test you over. I would say using the scanner on the exam is probably something you shouldn't be doing. You know, one thing that I think students kind of fall back on pretty often is instead of functions taking in parameters that operate on them, you know, you write a function, then inside the function you create a scanner and ask the user for their input. Typically, if I'm asking you to write a function, it's because I want you to write something generically that can take in some inputs and operate on whatever those inputs are. I'm not asking the function to go and ask the user through a prompt for inputs. So you'll probably lose points for something like that. So understand that the purpose of the scanner class is for reading in from some other source, like the keyboard, or we used it for reading in from a file. If we're doing file IO, I would probably, because I don't want you to have to memorize code. So I would probably give you the couple of lines of code to read in from a file, or I would tell you that exists a function that you know, returns to you the lines of a file as a string array or something like that. So if there's a situation where there's a couple of like 2 or 3 lines of, you know, not hard code, but it's like, you know, I don't want to have to memorize this type of thing, you would usually reference it. I'll either give it to you on the exam or not ask you about it. I don't want you to sit around and have to memorize stuff other than just what you should be experienced. Like you should know how to write a for loop because you should have written so many for loops by now that that's not a memorization thing. It's just been ingrained into your soul. But some of these specialty lines that you used for a homework assignment here and there is not something I want you to memorize. I probably would not ask a question that specifically required you to use a for each loop, but certainly a for each loop should be in your wheelhouse, where if you had a, you know, an array list of objects, it might be useful to be able to do a for each loop through that array list as opposed to, you know, a normal for loop that goes through bucket I is whatever. Not that that doesn't mean you can't still use a normal for loop. If that's more comfortable for you, that's fine. But there will probably be questions on the exam where a for each loop could be used. Make sure you do remember the difference in string comparison between Python and Java, where in Python, you can compare strings using the double equal sign, and it'll compare them for content, where in Java, comparing strings using the double equal sign will compare their memory addresses, not their contents. So to compare strings, you have to use the dot equals method. Definitely be able to write functions. Definitely be able to create classes. Understand public, private versus protected, mostly public and private. You know, protected is kind of a specialized type thing for when you're working with inheritance. And I probably won't ask you something specific about that, but you know, that idea of keeping fields private and then loosening the reins when you need to, I think makes the most sense. I give you some examples in here. Definitely static versus non-static methods. be able to, if I give you some documentation and ask you to show me how to call this method, you should be able to do it. You should be able to tell, is it a class method or instance method, and you should know how to call it. If it's similarly, if I ask you to write a class method, you should know to put static in front of it. If I ask you to write an instance method, you should know not to put static in front of it, so on and so forth. So I asked a specific question about this on the midterm. Pretty decent chance I'll ask another specific question about this on the final. It was missed a lot on the midterm when I warned you about it, I don't know, 2,000, 3,000, 4,000 times. So again, I'm warning you again, this is a concept that you need to know. And it's not just a Java thing. It translates into every single object-oriented language. Syntax for it might be slightly different, but the concept is the same. File IO, like I said, if I'm going to ask you to do something, I would just say, here's a function that does, I mean, it's important, but not something I'm probably going to test you on just because it's kind of inconvenient on a test. The stuff with big O notation, it's interesting. We talked about it for a class period, but not something I'm going to test you on. In 490, CSC 490, it's discussed at a little bit more length with some more advanced algorithms. You know, it's a theoretical way of comparing algorithms to each other in terms of speed. Not that it's completely uninteresting. It's just not an applied concept most of the time. Most of the code you're going to write, it's not going to matter whether you do it in the most efficient or the least efficient way. Computers are really fast, and it's just going to be okay. It's more of a theoretical computer science concept when you're getting into very specific examples where there might be a you have to choose the algorithm that's the most efficient because you're dealing with a mission critical type of situation that it will make a difference. All right, so like these slides here, interesting, but don't waste your time memorizing them. I'm not going to ask you anything about them specifically. Similarly, I'm not going to ask you about specific searchers or whatever, but you should have linear search down. That's just your for loop that goes through every element of a collection. That one should be in your wheelhouse. So if I ask you to search for something, a linear search will be sufficient on the exam. I don't know. If I'm looking for an extra question, I might ask something about. Oh, I thought I just got a notification that somebody was in the waiting room. Sorry. Sometimes if I'm looking for a extra question, I might ask something about polymorphism. So this certainly should be something that's in your mind somewhere. Having more than one method with the same name but a different number and or type of parameter. I would say it's unlikely I'll ask about it, but it's something you should know. We've written some stuff where we've had two different constructors, things like that. Okay, so that's the general gist for the exam. If I was going to kind of throw one sentence at it, it's I'm testing you over intermediate programming skills and algorithms, not over Android stuff or things like that. Okay, so remember the point of this class, it's the coding 2 class. So you should have gone from a beginning programmer in coding 1 to now be a strong intermediate programmer coming out of coding 2. So I'm going to be testing you on skills that will ask you to prove that you have those skills to me. You know, not some, you know, trick question that throws you a curveball or something like that. All right, so any general questions about the exam for right now? Like I said, if you go and review some of these things between now and Thursday and you have questions you want me to do some examples on Thursday, I'm happy to do that. And then we'll use the rest of the time to cover some additional stuff. But I'm happy to do any examples you want to see on Thursday. But any general logistics questions about the exam? Okay, so with that in mind, let's bounce back to our couple of slides here where I was going to introduce. So let's start off by launching a new activity, and then I want to talk about how to get information between activities, and that's when we'll introduce the Singleton design pattern. So I'm going to go ahead, I'm actually going to start a new project here. So I'm going to go to File, New Project. And like I mentioned, I like to start with empty activities. And we're going to call this guy multiple screen example, something like that. Language will be Java. I'll just leave everything else alone. We'll hit finish. I'm going to close this other one just so it's not in my way. All right. Then it's generating its using Gradle to run the initial project and generate all the stuff. Put this down here. First thing I'll go ahead and do, I'll just run this real quick, make sure I have a working emulator. I should have a hello world program to begin with. And then I'm going to go ahead and create a second activity. All right, so there's our hello world program. So we have a working starting point. So now underneath our code here, I'm going to right click. I'm going to create a new activity. It's going to be another empty activity. And I'm just going to call this guy page 2. Okay. I like to maybe do something like page 2 activity. I like to have my class names just like you've seen me do it with like the names for text views and things like that. I like to call them with something that reminds me of what kind of animal they are. So we'll call this guy page 2 activity. All right. And it goes ahead and it generates a layout for me as well. So generate layout file, it'll generate another file so I can design this guy in there. So I'll just go ahead and hit finish. So now I have a second activity here, and I also have a second page. Okay, so here's this guy. I'm just going to go ahead and I'll, as I usually do, I'll right click on my constraint layout. I'll where's the convert view? I'm going to convert it to a linear layout. All right, and right now it's horizontal. I'll change it to a vertical. Is it just horizontal by orientation? I'll change it to a vertical one. And just for right now, I'll just throw a text view in here that says page 2. And I'll bump the size so that I can read it. All right, so this guy will say page 2 when we get to this screen. All right, so what we want to do is we want to learn how do I go from one screen to another screen. All right, so we'll go back to our main screen here, and I'll get rid of this hello world thing. I'll convert my layout. And again, I just want to reiterate for those of you who are going to go over break and play around with Android. I know a couple of you are, asking me a couple of questions. You're already working on some apps. I choose linear layout because I don't focus on the interfaces. So this isn't necessarily the best way to make your layouts. It's the way that I can make layouts functional quickly. So part of your routine does not have to be to create a linear layout from your constraint layout. It's just what I do. And I usually make the top level one a vertical linear layout. So I'm going to go ahead and I'm going to give myself a button in here. And here, we'll just say press me. So there's my press me button. And now this guy is on my activity main. So this is the view associated with the main activity controller. We can remind ourselves of that if we go into main activity controller or main activity, we can see that the file it's using is activity main inside of his on create. So that is the view that gets associated with this controller. This is when I do that association. That's how they get linked. Okay. Now I'm going to go ahead and I'm going to write a function here. So we're going to say public void on press me button clicked. This guy will take a view v as a parameter. I need to import view here. All right, so now what we want to do is when we click that button, we wanted to go ahead and launch our second screen to get from one screen to another. All right. Now, the way that we do this is we ask the current activity to start another activity. So we say this dot start activity. Now, starting an activity requires an intent. All right, so before we do that, we're going to go ahead and we're going to create an intent. Intent I is equal to new intent. And when we build an intent, we build it with the class that we have in mind. Our class is going to be page 2 activity dot class. Oh, I need to give it this as the context. That's right. Let me explain that here. So an intent asks you to give it the current context as well as where do you want it to go. Now, there are different kinds of intents. I'm just showing you the one that launches another activity. Keeping it simple, you can then take and go and research other ways of other things you can launch. You can launch other applications, Google Maps, stuff like that. And all that is done through an intent. I intend to do something. So this is what we're doing. We are saying, I intend to do something from this context. That is from the current screen I'm on. So the context, like right now, I'm sitting in my living room. So that's my current context is I'm in my living room. So anything that I'm doing has to be done in terms of my current location in the world. All right. So that's when it says package context, it's looking for, you know, the current place that we want this intent to occur from. And then what are we going to do? Well, we're going to intend to launch an instance of this page 2 activity. Then when we start an activity, we pass it the intent. So this dot start activity requires an intent to do its job. Okay, so now I've written this function for on press me button clicked. Now I need to go and connect that in my activity main. So I make sure I select the button. I go to his on click. And here's my on press me button clicked. I go ahead and run the code. Here's my press me button. I click that and it takes me to page 2. Okay. Now, one difference for kind of one interesting definite difference between iOS and Android is you'll notice if you have the same application in iOS, you know, let's say it's like the, you know, weather.com or something like that. You're looking at the weather.com app in iOS versus the weather.com app in Android. iOS will commonly have back buttons built into the app. The reason for that is Android, the operating system, relies on the existence of a built-in back button. So the way that, and we talk about stacks next semester in the 300 class when we do data structures. So the way that activities are placed, when we just launched this activity, what ended up happening is we created an instance of our page 2 activity, and we pushed it on top of our activity stack. All right, so right now there's 2 activities still running. Our original one, our main activity, and then our page 2 activity, which is now pushed on top of it. Whatever activity is at the top of the stack, that's the one we currently get to see. All right, so if I hit this back button here, what's going to happen is the default back button tells me to go back to the previous screen, and that will discard the other activity. All right, now we can interrupt that. We can interject if we would like. So let me show you that. I'm going to go ahead and give myself programmatic access. Not that you'd want to do this, but you could do this. So I'll just throw it in here as kind of a trivia thing. So I'm going to go ahead and give my label here a name. We'll call this guy My Label TV. Okay. And this is on my page 2 activity. So I'll go to my page 2 activity. And I'm going to give myself access to this guy. So I'll say private text view, My Label TV. We'll set it inside of onCreate. This dot My Label TV is equal to this dot find view by ID r.id.mylabeltv. So now I have access to that. I have programmatic access to that label. So now I just start typing it, and when I find this thing called on back pressed. So I could say override here. Well, it automatically puts in that. That's a performance thing. Now, by default, it's just calling my parents on back button press, which is our app compat activity, whatever the back button is supposed to do, which magically pops the top of the stack off and takes us back to the previous one. Well, I'm going to not do that now. Instead, I'm going to say this dot mylabeltv dot set text to back button pressed. Hide this again. All right, so when that back button is pressed, rather than doing the default behavior, I'm going to just go ahead and do something else. So I'll go ahead and run this. And I'll say press me. And now when I hit this, it just says back button pressed. But now the bad thing is I no longer have a way of getting back to that previous screen. Okay, because I removed that that function. All right, now how can we fix that? Let's assume that I want this button to set back button pressed, but I want to put another button on the screen here. And maybe this guy will say go back, something like that. I want this button to actually take me to the previous screen. How do you suggest we do that? Everything you need is on the screen right here. I'll go ahead and start writing our function for public void on go back button pressed UV. So
would you just call this? Oh, sorry.
Go ahead. Go ahead.
Would you just call the super of on back pressed?
Yep. This guy already exists. So a app compat activity, he already knows how to go back. We suppress that by overriding the on back pressed function, but we can still call our parent's version of that function because he knew what to do. And that will now let us go back. We just need to now connect the dots and have our button actually call this function. So we'll go to the on click for this guy. There's our on go back button pressed. So we'll say press me to take me to that second screen. We see that our back button here still just, we've overridden it and it still sets this text. But now I can hit go back and it takes me to the previous screen. So I didn't lose my ability to go back. I just changed the functionality of this back button by making a more local definition of the on back pressed. But I still can call upon my parents' version of that through another button. All right, not that this is necessarily overly helpful, it's more just proof that you can do things like this, you know, and that if you take this to the next level, you could probably change some other default behaviors for things, and then, you know, but you still haven't lost original access. That's the point of the inheritance model, is because my page 2 activity is an app compat activity, we can't change app compat activities. Those guys, their abilities are set in stone. So he knows how to go back to the previous screen, among some other things. All right, we can suppress certain default behaviors, but we haven't lost the ability to do some other things as long as we build them into a different button or something like that. But one thing you will notice is if you look at an iPhone application, you'll usually have back buttons or a back arrow, something like that built into the application interface, where with Android, you won't, because Android has a built-in back button. Just something to kind of keep in mind. Now, but that has a consequence. And let's talk about that. So in Android, the OS maintains a stack of activities related to an application. So this, it actually runs your applications inside of a virtual machine type thing for security purposes. So it's a little bit more complex than I'm going to kind of advertise it as, but we can kind of assume that it is, in Android, you have a stack, which is all the current applications that are open. And those activities show up in a certain order. They actually show up in an order per activity, not whatever you've opened and it just goes back to that previous screen. If you've been an Android user for a lot of years, the earlier version of Android is that you could actually go back to another one of your running applications by hitting the back button, because all activities lived on the single stack, but now they live within their own little world. Doesn't necessarily matter here, but in Android, we have a stack of activities. In iOS, an application has its own hierarchy of screens named view controllers. So we can say view controllers are basically activities, but the way the OS handles them is a little bit different. They're largely the same kind of animal though. Okay, so the idea is that in iOS, we are in charge of transitioning between our various activities, and we can even change the way that transition occurs. You can do that inside of Android as well. There's like that, there's the default where it just slides out of the way, but you can make it slide up or slide down, or do some, there's some animation stuff you can do where it kind of flips over to disappear, that kind of stuff. So I would say you maybe have a little bit more control over it in iOS, but at the cost of just not having the convenience of just having the built-in back button that just takes you to the previous screen. Now, let me ask this question. Can you imagine, is there an example where you would want to override this back button? Can you give me a scenario where overriding this back button, I mean, let me take it a step further. Maybe we override this back button and we still ultimately want it to go back, but maybe it does something else beforehand. Can you give me a scenario where that might make some sense? Think about your mobile apps, the kinds of things that you go to other screens for. So let's say you're on the main screen of an app. You just downloaded it. Most apps have us log in, right? Well, let's say that you don't have an account. You have to register for an account. So you'll click a button that says register, and that'll take you to another page, right? Now that other page is going to probably have some text, some edit texts in it, text boxes that have you put in, your username, your password, confirm your password, that kind of stuff. And then when you hit, a lot of times they might give you a save button, or create an account button that when you create it, it creates the account, then also sends you back to the login page. But you could potentially say, I'm going to build in my create account into my back button. So you can click the back button, and before it sends you back, it can generate the account, tell you it was saved, that kind of stuff. So just to kind of give you a quick little example of something you can do in Android. We'll go to that page 2, activity. And on top of setting this label, I'm also going to do something called a toast. Let's see. All right, so we have this thing called toast in Android. I think the idea is it's kind of like, you're at a wedding and you put you're going to do a toast, just kind of a quick little saying that pops up on the screen for a second, then goes away. So we're going to use toast, make text. What kind of animal is make text? This is the first time you've seen this. So what kind of animal is make text? Is it a field? Is it a method? Is it a constructor? What is make text? Oh, so exciting today. Everybody's just happy to be here. It's a function. How do we know it's a function? How do we know make text is a function? Somebody's got to answer that one. I'm just going to sit here for the next 20 minutes if you don't.
It's got the parentheses after it.
All right, we got the parentheses. So we know make text must be a function because it has our parentheses there. All right, is it a class function or an instance function? Class method, instance method, static method, or a non-static method? And how do you know?
Static method.
Static, how do you know?
You know, because the word before it is capital, and that implies that it is a class.
Perfect. So we have this class called toast. Now we can look at this guy and say he is likely a class name because he is capitalized. And if you hover over this in Android Studio, it pops up and shows you that, you know, public class toast. This is one of, this is in the Android widget package. So we have this thing called toast. It is the name of a class. We're using the class name to call this method. So if I were to look at the definition of this method, we should see static in front of it. So right there, you see public static make text. All right, so it's a class method. So again, you just saw this for the first time a minute ago, but you're able to look at this and you're able to say, this is what it likely is. Now, if I was instead showing you this documentation, and in this documentation, you saw that we had a method that was inside the toast class. It was static. It actually returns a toast that we can then tell to show. We'll see that in a second, but it's a static method called make text that takes in a context, a string, and then how long we want it to be. So similarly, what's this guy right here? What is length long? What kind of animal is length long? Cat, dog, constructor, function, field. Those are your answers, potential answers. What was that?
Field.
Field. Good. How do you know it's a field?
There are no parentheses after it, and
No parentheses. Okay. Class field or instance field?
Class field.
For the same reason you gave me before, right?
Yeah, it's on a class.
Okay, so we're saying toast dot. Here's the field name. So length long must be a field. It's a static final int. It's a field called length long that lives inside of the toast class. It's static. It's an int. Now this final keyword we haven't looked at before, but that's a constant. It says you can't change it. If you make it final, this guy's stuck. Nobody else can, you know, through some other method, he can't go and make an adjustment to that. So it's length long it looks like its value is a 1, but point is by us saying length long, we don't have to know what its value is behind the scenes. It's just that the make text function of toast says, tell me what the context is, tell me what you want me to say, and tell me how long do you want it to show up on the screen. Okay, so that's what make text is. And then after that, we get a toast that we can then tell to show. And there's the show function. Notice that the show function is a instance method. So this guy right here, he boils down to a toast object that I can then tell to show. So if you didn't know anything about what T was here, and I asked you what kind of animal show is, you would say, oh, that's a method. How do you know? Because it has an open closing parentheses. And then I said, is it a class method or an instance method? You would say, well, it's likely an instance method because the guy who's calling it starts with a lowercase letter. Probably not the name of a class. Doesn't mean it can't be, but probably not. So T here is an instance of the toast class. It's a variable of type toast who got its value from calling the make text static function from the toast class. All right. Now, you didn't have to memorize any of these things. The important thing is if you were to start looking at some documentation, you would know how to call these based on that lesson of static versus non-static, fields versus methods versus constructors. Having that stuff ingrained in your soul is such an important concept that will be on the exam in one form or another. Might even be a couple of questions on the exam covering that concept. All right. So you can call it directly like I originally had, or you can use make text to give you a instance of toast and then use that instance to tell itself to show. And then I'll show you what this guy does. He kind of does this little pop-up thing that goes away on its own. Over to the screen. Now when I hit back, you'll see back press showed up down here. And then it just goes away. So that's the long toast. And then there's a medium and a short that has it show up for less and less time. Okay. So just another little widgety thing that can be handy. So now the question is, if I'm on this screen, and let's go ahead and let's read in a number. I'm going to put an edit text number in here. Oh, sorry. Actually, let's just get that value over there. We won't put the edit text in yet. So let's say that I have the number 5 on this screen. And when I hit press me, I want to somehow get the number 5 over here and have it show up where this says page 2. Okay, so I want this to show 5 from this screen, which effectively I'm saying I need to pass a piece of information from this activity to another activity. How do we accomplish that is the question. Okay, built into Android is this thing called put extras, where we have the concept is something called extras. So before we look at the Singleton design pattern, we're going to look at extras. This is like a suitcase that an activity, well, that an intent comes with, that we can stuff things into to get them to the destination. Okay, and let me show you that. So we'll go back to our code here. And on our main activity, after we have our intent, but before we start the activity, we're going to say I put extra, and it's just name value pairs. So we're going to say my number is going to be its name, and its value will be 5. All right, so I'm putting something into put extra, well, into my intent, who has a variable name my number and whose value is going to be equal to 5. Then I'm going to start this activity with this intent. Now my page 2, let me go ahead and give this, it's called my label TV. Good, we already have it. So my page 2 activity, inside of onCreate, we give ourselves access to my label TV. Then we'll say this dot my label TV set text. And actually, let's get our number first. So we'll say int my number is equal to this dot get intent dot get extra, get int extra named, and what was my name? My int value or something like that. Gotta make sure you have that. It's called my number. Oh, so when you get an int extra, you tell it the name of it, but you also can give it the default value if in case it can't find it. So I'll go ahead and get my int extra called my number, and if it doesn't find it, I'll just give myself a -1. Then we're going to go ahead and put in here the empty string concatenated with my number. All right. So when we get to this page 2 activity inside of onCreate, so this is still before it's shown up on the screen, we'll go ahead and extract our number from that intent. So we unpack our luggage, we grab our number called my number, store it in this variable, and then I just fill it up into that text with, I just do an empty string concatenated with that number. So we should now be able to get whatever number I passed in here onto this label when we first get to that second screen. So this time I passed in a 5. When I say press me, there's my 5. If I change this guy to a 31 and run it again, now I'll have a 31 that'll show up on that second screen. All right. Now, right now we're hard coding in a value. We might want to read in a value from the user. So let's go to activity main. I'm going to go ahead and I'm going to go under text things, and we're going to do something called an edit text. So we're going to read in something. Actually, I'm going to read in a number. So notice here, so this guy's an edit text, but so are all of these guys. So I'm going to choose the one that says number, because what it does is it associates a certain keyboard with it. So I'll actually put him above my button. All right. And then you can also put in a hint. Enter number here. So now he'll have some text in there that, but it not text you have to delete. It's just a hint of what you're expected to put in there. Okay. But it's already pre-selected the number keyboard for you. And let me show you what I mean by that. See, it says input type. It says number. So when I click on this guy now, it brings up the keyboard specifically for numbers. So if I click on this guy and I change its type, to I don't know, something else. Let's just say to text. This guy effectively just became my plain text version of this. So now you'll see when I run it, I'll just get a different keyboard that pops up. Okay. So that's the difference. These are convenient ways of you grabbing a function that had, or an edit text that had the right kind of keyboard selected by default. That way you don't need to necessarily make sure they've entered in a real number if they only have a keyboard that allows them to enter in numbers. All right, and we're going to go ahead and name this guy my number ET for my edit text. All right, and we're going to give ourselves access to that inside of main activity. So I'll create a private edit text, my number ET, and then inside of on create, we'll set this dot my number ET is equal to this dot find view by ID r dot ID dot my number ET. So now we have access to that guy. Now what we'll do is we'll go ahead and get our numbers. So when we press that button, we'll say int my number is equal to this dot my number dot get text. Now this gives it to you as something called an editable. To get the string version of we do that, but we actually want the int version of this guy. So how do we get the int from a string? Integer dot parse int and pass it that string. So I'm going to parse the integer out of whatever string is currently in my number edit text. I'll store that inside of my number, and then instead of passing it a hard-coded value of 31, I'll pass in whatever my number is. Okay, so now I'll say 45 here. I hit press me, there's my 45. If I change this to a 4, hit press me, now it's a 4. If I change it to just banging on the numbers, hit press me, now it's that number. All right, so now you know how to read stuff in from the user as well as send stuff to the next screen. Okay, but this is actually sending stuff to the next screen using something called put extras. Now, let's say I even had a third screen here that I wanted to send stuff to. So I had another button that said launch screen 3 or something like that. Now I had a third screen, and let's say I wanted that third screen to also know about this number. Now, one thing I can do is I could just put into extras that same value. So just kind of, you know, like, oh, the next guy needs it, no problem, I'll just pass it along. But let's say you have multiple screens in your application that all kind of need the same value. Like, for example, when you log in to an application, a lot of times you might have your first name, maybe all the different screens in the application, you know, maybe for me it says, hi, Mike, you know, welcoming me to the app, you know, come buy our crap, whatever it is. But, you know, that's that one piece of information, the person's first name, for example, might need to be known by all the screens in the application. So then you can say, well, do I really want to just pass this around where every single time I have a new screen, I have to kind of embed it into extras? Well, you could. I mean, that would be fine, not the end of the world to do that. But is there a better way? And that's where we have the idea of this singleton design pattern. So design pattern called singleton. Let's just put that on another slide. The singleton design pattern, and again, remember, design patterns are not implementations. They suggest an idea, but rely on the end user to come up with their implementation for it. So, for example, MVC, Model View Controller, says it's a good idea to keep your data, your interface, and your code separate from each other. That's fine. Android handles this one way. iOS handles it in a similar but different way. Unity game development handles it in an even different way. But they all have that same concept of the MVC design pattern within them. All right. So singleton design pattern says it is a good idea to store values that need to be accessed by, I'm going to say many, and I'm going to put it in the context of Android here, by many screens in a single place that they can all access. Okay, so this is the idea of a singleton. Now, one thing that's interesting is if I go to my project here and I right click and I say I want to create something new, notice one of the things, I think it's still in here, singleton. Oh, it used to be in here. Oh, maybe under other. No. Well, maybe they finally joined the club then. I was going to say that built into Android Studio, one of the options here was to add a singleton. It's got to still be here somewhere in one of these folders. I don't like the way they implement it. So I implement my own singletons. And it's something we're already used to. So I'm going to go ahead and I'm going to just right click here. I'm going to create a new class. This is going to be a plain Jane Java class. And I'm going to name this guy. I a lot of times name my singletons, I just call them core. For no good reason, I don't know. I started doing it years ago. Kind of like a core library, a core place to find stuff. And then inside here, I'm going to create a static int, my number. And maybe I'll default it to -1. That's it. That's all I'm going to put in there. So now back here in my activity, rather than putting this in extras, I'm going to say core dot my number is equal to my number. Then I'll start my activity. And over on this other screen, rather than get it from my intent, I'll just say core dot my number here. So I didn't have to add it to my intent. I didn't have to extract it from my intent. I'm just grabbing it from my global object that has a bunch of static stuff in it. Right now it has a single static integer. So I'll put in my number here, 56. I hit press me. This will put it into core dot my number. And then I read it from core dot my number right here. Now, I'm guessing most of you would say that this seems more convenient than adding it to my extras and then extracting it from my extras, especially if I was having to do this on multiple screens, because now I can create a third screen that just as easily can grab core dot my number. So that would be an example of a singleton. Now, the reality here is, though, is with great power comes great responsibility. This is nice and convenient. When you need to share something between multiple screens, you might be tempted to just throw everything inside here because it was nice and convenient. The reality is, though, is that for a large application, your singleton can get pretty large. Now, you can create multiple singletons, multiple classes that maybe have different, different kinds of stuff in them. But I would still stick to this rule that unless you need to share stuff between more, I put in the notes, many screens, you can decide what many is to you, at the very least, more than one. So you can say 2 or more screens. Okay, if you have to store stuff with many screens, it might make sense to put it into a singleton so you can conveniently access it from all of those screens without having to continue to pass the value around. All right, that makes sense? Questions about singletons? Okay, I'll go ahead and push this code just so you have something you can look at if you want to mess with it a little bit. Homework, I guess unofficial homework for Thursday, is start reviewing for the exam and show up to class with some questions that you might have for the exam. And I'm happy to go over any code examples or whatever. And then we'll look at something called an array adapter that allows us to have a scrollable list of strings. If you've been on an app and you get a big list of stuff and you can kind of scroll through it, I'll show you how to do that in Android. All right, questions, comments, concerns, bribes. All right, I'll see everybody on Thursday. All right, it's up on GitHub now.